Hello students, this is Physics by Gaurav. In this video, we will try to understand one topic that is very interesting, that is acceleration due to gravity. It is a very basic topic, okay? It is generally taught in the schools, the high schools, class 6, 7 or 8, but it is a very fundamental topic to understand the gravity or further topics of the gravity. So we'll try to understand acceleration due to gravity through a definition and also through a mathematical expression. First, we'll try to understand the definition of the acceleration due to gravity. Okay, the definition is that when a body is dropped from a certain height above the ground, it begins to fall towards the earth. Under the gravity, the acceleration produced in the body due to gravity is called acceleration due to gravity. It is denoted by small g. Its value is close to the earth's surface, is 9.8 meter per second square. Now you see that whenever a body is dropped from a certain height, okay, let us suppose when a body is dropped from a certain height above the floor or above the ground, okay, it will obviously be attracted towards the earth. Why? Because of the force of gravitation. That's obvious. So we have learned in the previous video. If you haven't understood the gravitation topic, you can check out my last video that was on gravitation topic, the force of gravitation. So when a body is dropped from a certain height above the floor or above the ground, the body will fall towards the earth. Because why? Because the body is attracted towards the earth due to the force of gravity. Okay. Now, when a force is acting on a body, that is obvious that there will be acceleration produced in the body. Now, here also, when a body is dropped from a certain height above the ground or floor, it is attracted towards the earth due to the force of gravitation. Now, due to this force of gravitation, an acceleration will be produced in the body. So, the body will be accelerated towards the surface of the earth with an acceleration. Now, that acceleration produced in the body due to the earth's force of gravitation is called acceleration due to gravity. Okay. The acceleration produced in the body due to gravity is called the acceleration due to gravity. Now, it is denoted by small g. Its symbol is small g. You should remember there is a vast difference between small g and capital G. Small g represents acceleration due to gravity and capital G represents the gravitational constant, that is universal gravitation constant. Now, its numerical value close to the surface of the earth is 9.8 meter per second square. Okay, now that means it is fixed. The value of the acceleration due to gravity that close to the surface of the earth is 9.8 meter per second square. That is fixed value. Okay, now we have understood the definition. Now we will try to understand this topic with the help of one diagram. Okay, let us consider this is the earth. Okay, this is the earth whose mass is denoted by capital M and the radius is capital R. Okay, now let us consider there is a small body of mass small m, okay, and it is falling towards the earth. Now this m we have made a consideration in this diagram that this mass m is very close to the surface of the earth. Okay, this mass m is very close to the surface of the earth. That means the distance between the center of the earth and the body can be considered as the r. Why? Because this distance between the body and the surface of the earth is negligible. Why? Because it is very near the surface of the earth. So the distance between the body and the center of the earth can be taken as the radius of the earth, that is capital R. Now when a body is falling towards the earth, it is attracted with a force is equal to, we know the force of gravitation formula, that is G, capital M, that is mass of the earth, small m, that is mass of the body, by R square. What is, where R is the distance between the center of the earth and the body. Why? Because the body is very near to the earth, so this distance has been ignored. Now we have got the first equation, that force is equal to G, capital M, small m by R square. Now the force acting on the small body can also be taken as mass into acceleration according to the Newton's second law of motion. That means this F dash is the force acting on the body. This is also the force acting on the body. This is the total formula. This is the force of gravitation acting on the small body. Now this is the gravitation force formula. Now according to Newton's second law of motion, we get another formula, that force acting on the small body m is equal to mass into acceleration, okay, where the m is the small m is the mass of the body and a is the acceleration produced in it. Now when we rearrange this equation, we get the formula for acceleration acting in that body, which is a is equal to f dash by m. That means the acceleration produced in the body is equal to the force acting on the body divided by the mass of the body. Now this force acting on the body is nothing but the force of gravitation acting on the body, which is f is equal to g m by r square. Now f dash is nothing but f is equal to g m by r square. Now we will put this the value of f in the place of f dash. Now acceleration will be g m by r square divided by small m. Now small m will get cancelled. So what we get, the formula for acceleration acting on the body, the capital G capital M divided by capital R square. So this acceleration produced in the body is due to the gravitational force of the body. That means this is due to gravity. That's why this acceleration is called acceleration due to gravity, and it is denoted by small g. So this acceleration A is nothing but the acceleration due to gravity, that is small g, whose formula is capital G capital M by capital R square. Now this capital G is nothing but the gravitational constant. This capital M is nothing but the mass of the earth, and this capital R is nothing but the radius of the earth. Now we know that the gravitational constant is a fixed value, it's a constant. The mass of the earth is also a constant value, and the radius of the earth is also a constant value. That means the value of the acceleration due to gravity is a constant value, that is equal to 9.8 meter per second square, that we have discussed earlier. So we see that the acceleration due to gravity is equal to gmm by r square, whose value is fixed. That means acceleration due to gravity is a numerical value, it's fixed value, okay, it doesn't change with any situation. That means we see that acceleration due to gravity is free from m. It does not depend on the mass of the body. That means the acceleration due to gravity does not depend on the mass of the body falling towards the earth. That means whichever body will be falling, however body will be falling, it will not, the acceleration due to gravity will not depend on the mass of that body or shape of the body, size of the body, density of the body. It doesn't depend on that body itself, okay, it is independent of the body falling towards the earth, okay, its value is the fixed value. That means we can think that if two bodies of different masses are allowed to fall freely, they will have the same acceleration. That means let us consider that there are two bodies falling towards the earth. That is, one body is of mass m1, second body is mass m2. Now when they fall towards the earth, both of them will have the force of gravitation acting on them. Now due to those forces of gravitation, acceleration due to gravity will be taking place in them. Acceleration due to gravity will be taking place in them, and we know that the acceleration due to gravity will be same in both the cases. Why? Because the acceleration due to gravity is a fixed value and it does not depend on the mass of the body. So whatever be the mass of the two bodies, m1, m2, whether m1 is greater than m2 or m2 is greater than m1, it doesn't matter. The acceleration with which both the body will fall towards the earth will be same. That means acceleration of mass m1 and acceleration of mass m2 will be same. Now, thus we understand that if two bodies of different masses are allowed to fall freely, they will have the same acceleration. That's why you must have seen this experiment, the feather and coin experiment. It is very important experiment. Now, in that experiment, what was done, that a feather and a coin was allowed to fall from the same height. Obviously, the coin fell earlier and the feather fell after some time. Now you must be questioning, sir, that right now you have said that the mass of the body might be different, but they all fall with the same acceleration. That means they all should fall, both the body, that the feather and the coin should fall at the same time when they are made to fall from a fixed height, that is the same height, okay. Now why does this happen? Now the same experiment, if it is conducted in a vacuum tube, that means let us consider there is a vacuum tube, and inside the vacuum tube a coin and the feather are made to fall from the same height. Now both of we see an amazing thing that both of them fall at the same time. Both of them fall at the same time. Both of them hit the floor at the same moment. That means acceleration produced in the feather and the coin is same. Now you see that in the first case, when it was made to, both of them was made to fall under the air condition or outside the vacuum tube, it fell differently, at different timings. Why? Because the force of resistance was acting on that feather. Force of resistance was obviously acting on the coin also, but it was very negligible. But the force of resistance acting on that feather was quite large. Okay, that's why it fell after some time. But in the vacuum tube there was no air, so there was no force of resistance acting on either the coin or the feather. That's why both of them fell at the same time. Thus we see that acceleration due to gravity is a fixed value. When there is no resistance, then both the bodies or any two bodies will fall at the same time when they are made to fall from a certain height. Okay, so I think so this acceleration due to gravity topic you must have understood. So I think so definition must be clear. The mathematical derivation of that formula of the acceleration due to gravity is must also be clear, and the experiment that I made you understand also must be very clear, though I should have made you understand with the help of a diagram, but I couldn't do so today. So I think so this topic is very much clear to you, and I hope you like this video. And if you like this video, do like, subscribe, share, and also do comment in the box if you want to learn any topic, any particular topic. I'll be continuing to take some videos in the future, though I'm not regular right now, but I try to be regular now. At least in a week 4 to 5 videos I'll be uploading in the YouTube. So I hope you like the video. So thank you for watching. Thank you.